All right, we're live.
You want to count it down so we can
Oh
get some
yeah.
people joining in?
Never mind, guys. We're not live. I mean, we're gonna stay live, but we're gonna count down to let people in. So yeah. All
That,
right, we're live.
that music's something, you know.
There's gotta be some other options for music.
Yeah, that's different. I'm
I
not sure
mean,
how I feel about it. I don't know. Maybe people might like it. I don't know.
yeah,
Um,
I don't know. Hey, there's like some Christmas one. I mean, it's not Christmas anymore, but there's some other cool background ones we could use. It looks like you can upload your
I
own
mean,
too.
smash the like, the love buttons, smash the share buttons, hit them, hit them, hit them, um, and yeah, share it. Share it away. Share it away with your friends. Share it with your family. Share it with your enemies. Even we might be your enemy after this one. Share it with us. Who knows? You know. Um, Before we get into the analysis, I would like to make sure that folks understand that if there's any BS behavior going on in the comments, we will block you. Um, we're not going to deal with it um, today. Just so you know, this forecast has become a very tricky one, a very challenging forecast. We're going to give you the information. We're going to show you why it's different and what's going on. But I will not tolerate it today at all. So we're going to get into a good analysis for you. We're going to give you the best we got, and we're 48 hours away still. We have some things we need to work through, and that's what we're going to do. So, Brett, I would like for you to take it away. Lead us off.
Yeah, well, let me sum up first, just to give everybody an idea of what's going on and be completely transparent. There, we went from a forecast that pretty much all of the model data was on board and completely consistent and had a very good idea of what was going to happen to uh, after we got off last night, overnight, model runs completely diverged. We've got the European and the Canadian models that have trended well south and weaker with the storm system. We've got the GFS and the German model, and it looks like the high resolution American data that comes in within 60 hours or so, that still going to have really heavy snow across central and potentially southern Indiana. And so as we've gotten closer, the data has actually gotten farther apart, which is not how it's supposed to happen or how it should happen. And so the whole reason, guys, that we didn't do a live at 10 a.m. this morning is because we wanted to wait for the midday data to come in to make sure that we were giving you a forecast that we could feel confident in. And to be honest, the midday data didn't help us that much. We thought that it would, it didn't. And so we're really going to spend some time talking about the risk to this and what we're going to have to just watch over the next 24 hours of runs. We've got about 48 hours or so still till this really starts to ramp up into Sunday afternoon and especially into Sunday night. And so we do have time, but just to be completely transparent, right now, confidence is lower than what it was 24 hours ago, and that just is what it is. So, do you have anything to add to that, Michael?
No, I think it's great. It's a great explanation of everything. When you think about we've for 5 straight days we've had basically everything that we have access to that meteorologists can look at for 5 straight days for 50 straight runs has all said the same things. And now today they have um, kind of split down the middle. So you do what you can do. So that's what we're going to do.
Yeah. Well, I will. I'm going to get started. What we're going to do, I'm going to share my screen, and what we're going to do. What do you do? Are you throwing stuff in there?
No, I'm moving someone. I have a glare, and
Yeah, you do. It's okay.
Okay, is it better now?
Yes.
Okay, I'm smoking a cigar. I smoke cigars on Fridays. Someone already said that I've disappointed them because I'm smoking. Sorry. Share it with a friend. Michael's disappointing us.
All right. So I'm gonna. Sorry that Michael's disappointing you. You could have worse habits.
Yep.
What we're going to do is show you kind of the two ends of the spectrum that we're going to be dealing with this storm. The GFS, which is more aggressive and further north, and the European, which is weaker and further south. By the way, that's the opposite of what their normal biases are. Normally, the European's stronger and further north, and the GFS is weaker and further south. So that's another odd element to this system. Is the biases are backwards. Their normal errors are the opposite. So that just adds even another layer of kind of uncertainty. But we'll get into that. And so let's start with the GFS. I would say the one area that we do have a lot of confidence in of getting some very, very heavy snow is northern Missouri, northeast Kansas, and southeast Nebraska. I know we have some YouTube followers and some Twitter followers out in that region. That's one area that both models agree on, and that will likely have some very heavy snowfall totals, some very heavy snowfall rates Saturday night into Sunday morning. And then you can see this GFS model here as we get into the afternoon on Sunday, brings in a very heavy wave of snow into central and southern Illinois, central and southern Indiana, and continues that throughout the afternoon and evening hours on Sunday. Now, I'm going to pause it here. That's a funny comment. That would be nice if we could do that. I'm going to pause it here because this is really where the differences, I think, really start. Both models have kind of this first wave. But the GFS continues to bring the heavier snowfall totals north, and it keeps it around for a lot longer than what the European model has. This also leads to ice coming further north into southern Indiana, kind of Bloomington and Point South. It brings ice in. It still has a little bit of this gap where we could maybe get some a lull in precipitation or maybe some sleet, freezing rain mixed in. But then the second big difference is it still wraps in what we call this deformation band. When you get a stronger low on the northwest side, a lot of times you typically get a heavy burst of snow as the low pushes off to the east. When you get a weaker storm, the colder air rushes in faster and you don't get that. And so the GFS still has a strong hit with the first wave. And as we work into Monday morning, Monday afternoon, brings in a strong hit with the second wave. It's basically a 24-hour storm. It's a long duration storm, and it hits us with snow really big twice before it exits off to the east. Now, we're going to compare that to the European model. Let me zoom in here, see if I can get those ads off the screen. This is Weather Nerds, by the way. They do an awesome job of having customizable zooms. And so if you're looking at weather data and you know what to look for weather data, Weather Nerds is a nice site because you can zoom in anywhere and kind of customize your zooms. So again, guys, really no disagreement with what's going on out here in northeast Kansas, northwest Missouri, southeast Nebraska, some very heavy snow across that region as we go throughout Saturday night and Sunday morning. Now, we do have this wave that comes in as we work into Sunday evening, but the heaviest snow is across southern Indiana, and it generally stays south. It doesn't really lift north. You can see the core of the freezing rain stays well south in Kentucky. And so that's the first big difference is that heavier snow band and that freezing rain line never comes north. And so the heavier snow never makes it into central Indiana. And because the storm is weaker, you're basically getting all of the precipitation out by middle of Sunday morning or Monday morning, excuse me. There's no second wave. The deformation band never forms, and you have no second wave at all. So you're lighter on the first wave, and then there's no second wave. So we've just got massive differences between these two models, and you can see what that leads to. We'll go through the European model here. This is the 6Z run. The 12Z was almost identical to it. It's not in on this site yet. Here's what it does. This is by 8 p.m. on Sunday. This is by 1 a.m., 2 a.m. on Sunday. And then as it exits out, you can see it keeps heavy snow. I mean, honestly, 6 to 10, 8 to 12 inches along the Ohio River. And gosh, I mean, 4 inches in Bloomington, 5 inches in Columbus, light snow along the I-70 corridor. We compare that to the GFS. We go over here and switch to the GFS. You can see for the storm total, it's got more than a foot of snow along the I-70 corridor, where the European model basically has nothing. I mean, not nothing, but very light. So just to go through the massive differences here, and I know Michael's going to talk a little bit about why these differences are the way that they are. But again, just to be completely transparent, the GFS has stayed consistent. The Europeans shifted south. Canadian data has shifted south. Looks like the high-res data may at least be starting more north. We just have a split in data that we're going to have to sort through over the next 24 hours.
Yeah, Brett, one thing I would like to say too is in showing these, if I can share my screen, in showing these solutions here, see if I can go to this one. when you look at this,
real quick, because I saw a snarky comment in here and I'm going to address it.
Oh, good.
Somebody said, moral of the story, y'all, is don't even consider a snow forecast until 12 hours out. That's ridiculous. Yeah. Forecasting is always going to be difficult. And sometimes you can nail it perfectly at this distance and sometimes you can't. And we're servicing clients that are managing thousands and thousands of dollars or more of decisions. And you just simply can't ignore everything until 12 hours out. It's just not feasible. People need to prepare. Snow removal companies need to prepare, need to salt, prep, plan. That's a ridiculous thing to say, and you just can't do it. So.
And also the moral of the story is that it should say, moral of the story is you shouldn't consider a snow forecast. Anyway, sorry. All right, we're back. Anyway. We're back in action.
Sorry,
I'm going to get derailed. See, a lot of people that are watching right now probably have never watched before, and I don't think they know that I don't know. Sometimes I'm not very nice. I should be more nicer. Anyway,
and I'm being more spicy than normal too. So
yeah, I like the spiciness, guys. There's 10,000 of you watching right now. Here's what I want to say. Okay, if you've never watched us before, welcome and thank you for watching. I do genuinely appreciate you watching, your support. This is the situation, the model on the right and the model on the left. This is the European and this on the right, and this is the GFS, the American on the left. And so we just need more. We need more time. We need more data, and we're going to show it to you like it is. We're gonna give it to you like it is. Again, like I said, for those of you tuning in just now, we had 5 straight days of every model in the planet showing the solution you see on the left, which is the GFS. I mean, actually at a point, we've got several meteorologists in our office, and we were asking ourselves, good night. We've never seen this much confidence in a storm, in a model this far out, and all this data. So, just so you all know, this is just as frustrating and challenging and difficult for us as it is for all of you. And so we're trying to just give you the best that we can. But here's the deal. This is the differences. Okay. GFS, American model on the left, European on the right. Now what I want to show you is, I want to show you what's happening. This is a little bit more of a technical discussion, but I'm going to show you right here. You can see on the left, that's high resolution data. That's one of the American model data. It's called the NAM3. On the right is the European. And simply put, what's started to happen is we basically have 3 trusted models that have taken the European side, and we have 3 trusted models that have taken the American side on the left. And the difference is that on the right, what's happening is the low is essentially going weaker, it's closing off, and it's starting to transfer energy and give it away to the East Coast. It's positive tilting quicker. In the world of meteorology, we call that a positive tilt area of low pressure. All right. And what's happening is the Euro says, hey, we're going to do that faster. Now, here's what I want to say. I want to say this to you guys. These storms have a history. They have a history of sometimes getting rid of the energy too quick off the east coast. Okay. They've had a problem in doing that sometimes. Sometimes in this distance, this 48, 60 hour window out from the storm, the models kind of go south, and then as you get closer, they come back north. That's also something that we've got to keep an eye on. What's happening is the models are trying to resolve whether they're going to do the solution on the left, keep the low more neutral to even negative tilt, or the solution on the right, positive tilted faster. I want to show you this screen. Okay, I want to show you what I'm talking about. You can see it in motion. I want you to see the line near Iowa and then near Nebraska, these two lines, how they're pointing due north. All right, I want you to look real closely at that. They're pointing due north. Okay, the 552 line. It's a straight south to north orientation of the area of low pressure. It's neutral, and it's even a little bit negatively tilted. So what happens is the storm stays stronger, and it stays further north. And listen, the shifts on this stuff just are not finished yet. So we can't come out here and go, well, here's the forecast. That would be foolish. We're not going to be able to say, here's the takeaway for the forecast today, because we're not going to know. It's not possible. We can discuss the different solutions. Now, here's what the European does. The European, it is a totally different take on this. It's much quicker. You can see as I clicked on it, if you can see the negative tilt now, or the positive, if you will. I'm sorry. You can see these lines are pointing more to the northeast. Watch this. Okay, the low opens up, and watch the colors go to the East Coast, and it connect with the vortex in Michigan. You see the colors connecting there in Michigan? That storm links up, creates a bigger low there off the coast. It transfers the energy right there. It goes into a big storm. So the European does this much quicker. All right, the low weakens faster. It's a weaker area of low pressure, and that's why you get the weaker solution to that. You go to the GFS, which is the comparison, and it does not do that. Right? We go back to this. Look at this right here. You're still at hour 60 on that neutral tilt. You go forward, your low is still closed off. It's not giving energy to the northern stream. Go again, it's still not giving energy away. It's not transferring. It's still somewhat neutrally tilted. It could be slightly positively tilted, but not near the European. Mm-hmm. And then here, this is where it starts to open up and transfer. So the GFS is transferring about 24 hours later than the European, which is why it's exactly why you have this particular scenario. That's why it's happening. So the model on the right could be exactly correct, and the model on the left could be exactly correct. That's the deal. And there's no way to know which one's going to be right, which one's going to be wrong right now. You can't do it. The Euro typically has the upper hand in the situation. Typically, Brett, the Euro is what you see on the left and the GFS is on the right.
Yeah, normally if there's ever a bias, it's the European being too north and too heavy. We've seen that in recent years too, of the Euro throwing out some crazy totals and then backing off as it gets closer, while the GFS is too light and trends north and stronger. So again, it's just odd. And again, Troy said he's a big fan of BAM, since his comment was the one that made me go on my spicy rampage. So I do want to say thank you, Troy, and just say that I'm just trying to defend the forecast a little bit, because if we weren't confident in it, we wouldn't have done it. And it's so important to give our clients updates, and we're passionate about that.
I wanted to touch on this comment real quick, Brett, that I posted. They said that the pink is ice. No, on this particular screen I was sharing, that's just heavier snow. This is just snow only that I'm sharing, by the way. I don't want people to get confused. It's just showing heavy snow of a foot or more. That's what that means.
Yeah, and I think that as we get into it, probably this evening, we're going to start to get a little bit of a better idea of what the high resolution data is going to show. We're going to start getting into the territory of the NAM3 and the HRRR and whatnot, and sometimes those can see the subtle differences Michael was talking about a little bit better. They're a little bit higher resolution, so they can see some of the small features a little bit better, and the small features can make a big difference when you have differences like that. And so, I think that maybe by tomorrow morning, surely by tomorrow morning, we've got a little bit of a better idea. Knock on wood, right?
Yeah, I think so. I mean, again, we're in the business of predicting the future, and that's what we're doing here, and that's what people need to understand. It's just not always going to go the way everybody wants it to go. you know, it's not always easy when you're trying to forecast the future. I'm going to show one thing, Brett, to your point on the high resolution data. This is what I want to illustrate to you. Watch the high res data and watch how nice of swath of snow it has. Watch how strong the low pressure is down here in eastern Arkansas, western Tennessee. That's what this solution that you see right here, by the way, this was the solution we saw on all the models all week long.
Mm-hmm. Yeah.
This is what we've seen for 5 straight days. And then all of a sudden, a couple of the models decided they weren't going to show that anymore. For example, and I'm going to show it, the European did this. It just decided that it was going to take the low is much weaker and it's further north, and you don't have any nice defined banding of snow going on. So that's the difference. And it is, I do like that we do have some high resolution data that is still supporting the initial idea that all the models had. Um, but I will say this is the idea. This is the thing, real quick, um, that we want to mention is we talked a lot about this in our streams all week. It's not set in stone. It can change. We're worried about dry slot. We talked about sleep potential yesterday. We talked about all this stuff. The problem is a lot of people only hear what they want to hear. We can't guarantee these models are right. And when they start diverging, the best thing we can do is an expert analysis like this and tell you what we think. But Brett, this is all powered by our friends at Express Steel, yeah?
Yes, I didn't want to forget about our friends at Express Steel because there's 10,000 of you watching. So, wherever you're at, from Louisville to Indy, probably going to need some snow pushers as we go over this weekend. Obviously, Louisville's got the ice concern too. We should probably chat about that a little bit. But they've got their holiday sale. Today is the last day. And so if you need snow pushers, 10% off attachments, $100 off pushers, 5% off tracks, 10% off hoppers. And at checkout, if you use the code BAM, you can get $100 off, which is awesome on their snow pushers. And again, in the top left, look, it says it right there. We talked about this. Free shipping to the lower 48 states. How about that? So go ahead and get your discount. Get it shipped free to you anywhere in the lower 48. I know we have folks watching from Kansas City to Indy to Columbus, Ohio, and probably Louisville and Lexington too. Be sure to give ExpressSteelInc.com some love. Reach out to them. Be sure to let them know that BAM sent you and you saw their information from our live streams.
Brett, I'm going to take over on sharing and go into the ice situation that we kind of mentioned. Um, this is one particular kind of look at the potential icing. I think you had some graphics too worked up that you wanted to show.
Yeah.
Yeah. I just wanted to show at least the potential significance here of the icing in southeastern Missouri, southern Illinois, southwestern Indiana, and the northern Kentucky. Some of these folks could see a 1/4 inch or more of ice. What data did you think was best fitting right now for that? This is in the Clarity platform, by the way, which you can scan that QR code and you can sign up for our Clarity platform. Where, by the way, we have been updating our clients all storm long. We put out multiple great analysis and updates as well. It goes right to your mobile device, so you can get that. But Brett, what did you have?
Yeah, so I wanted to also kind of show the differences because the strength of this storm will also matter a lot for ice. believe it or not, but the ice accumulation might actually be higher with the weaker storm. And I know that sounds weird, but just to kind of explain a little bit of what happens with ice is typically the worst ice events are steady, light to moderate freezing rain events without a lot of wind, because that allows for the ice to accrete and to grow a lot faster, a lot better. If you have super, super heavy rain with wind, you're not going to build the ice up quite as well. And so here's the GFS. You can see along the Ohio River, it still has quarter to at some in some places 3/4 of an inch of ice. But if you look at the European model, it is further south, but it's actually heavier. You can see darker purples and blues in here. And that's just because it's not quite as windy as the GFS and the rain isn't quite as heavy. And so it actually accumulates a little bit more. And so it's kind of counterintuitive a little bit, but the weaker solution may actually be worse for ice down towards Paducah, down towards Lexington, Elizabethtown, Evansville, in those areas there. And by the way, this map specifically is sponsored by our friends at Nice Construction Services. Really, really awesome guy reached out to us earlier this week. Super nice. He watches a lot of our live streams. He is powering this particular map. Be sure to give him some love and check out his business for the Indy area, Central Indiana, Nice Construction Services. And again, right now, I think that if I had to make a bet on ice, probably somewhere between the two. And I say that just because, to be honest, sometimes the European is one of those models that overdoes ice a little bit. But I also think the GFS could be even a touch too far north with some of this ice working all the way north of Bloomington. So a mix of the two, regardless, if you're along the Ohio River and into northern Kentucky, southern Illinois, both of these models have some decent ice accumulations. You're going to be dealing with widespread issues, power outages, and certainly major travel concerns as we work into Monday.
Yeah, I wanted to share this comment here. Garrett said, is it common for winter models to move south and then shift back north? Yes, it is. It does happen. It's actually a thing. At least it used to be. I believe that it still can be, that can be a risk associated with the overall forecast here. Had a lot of people asking if we can share the snow map again. I'll share it again, or at least the ones we were talking about. But I want to make sure you guys understand, if for those of you just tuning in, that this is a one model solution. On the right's the European, and the one on the left is the GFS. And so we don't have one that we're going with yet. We're going to keep it waiting for more data. So we have some high resolution data that is snowier, like the GFS on the left, and we have some that is not, like the European on the right. In fact, some of the, there's data even further south than the European, and there's some data further north than the GFS. So we're 48 hours away, especially here in the Ohio Valley, before we get a little bit more confidence. So we'll have to just keep everybody posted. So
somebody asked a question, and it's gone now because we're getting so many comments. But somebody asked a question if we could use analog data or AI or something to help with this. And I just looked. I pulled up the SIPS analogs to see if they were any help at all, and they have the snow north of I-70. So to answer your question, no, it doesn't help. There are a couple of years, I don't know if you remember them, Michael, but 2014, February 5th is one on here. 2007, February 13th, but not a lot that I'm super familiar with. The 2014 one maybe was something, but not a lot of help here.
Bottom line is, this time tomorrow morning, we'll have better information for you. someone says, why are so many weather predictions drastically different? Yeah, listen, there's 50 different weather models to pick from, and some people are going to pick the ones they want to show the most, that they like the best. The difference is this week, every model showed the same solution. Like, you couldn't pick a different solution. So you have to understand that there's just different outcomes, and you can't pick one or the other and say another one's wrong. There's just no way to know that. You just can't do it. You have to present risk factors and possibilities of outcomes, which is what I'm going to show. The last map I'm going to show here as soon as Brett talks about this, but I'm going to show the probability maps, and we're going to sign off because we're going to wait for more data. All right. And we'll come back live again after we assess the data. We don't know what time that's going to be yet. We'll keep you posted. What's up, man?
Come on, man.
How are you? Good. Oh, thank you. So, sorry, we got people coming to say hi. But we will assess the data that comes in this afternoon, and if we feel there's a need to come back, if anything's changing, we'll come back and update you all for sure. Make sure you subscribe to the YouTube channel. You're following the X and the Facebook pages. Follow along. We will keep you posted. And we'll get another batch of weather models in here starting pretty much right now through about 6 p.m. We'll get the high-res data start rolling in, and then, we'll update this afternoon. So I want to show you one thing, and then we're going to wrap up. We'll take some questions. There's probably going to be 60 million questions, but I want to show one thing. I'm going to go over here to the Clarity platform and I just want to show probabilities. This sometimes can help you understand what the potential outcome is. All right. This is the probability for 4 inches or more of snow in 48 hours. The first dashed line that you see, that's 50% or higher. The second one is 75% or higher, and the third one is 90% or higher. So you can see this particular, right now, the blend of all the weather models, particularly favoring the best solution or the best potential for snow to be north of 4 inches, is going to ride all the way across the I-70 corridor from Pittsburgh all the way out to stinking Kansas City, and you can see it. You can see the storm just riding straight west to east. That's the percent potential of 4 inches or more. Okay, so that you see down here right now in Columbus, it's showing 91%. In Indianapolis, it's showing 76%. There's a sharp cutoff in Lafayette. It's showing 33. Okay, so this is the probability of seeing that. We can take that to the next one and go to 6 inches. All right, this is the probability of seeing 6 inches or more of snow in 48 hours. Again, riding along and south of I-70 right now based on the blend of all this model data. The bullseye is 82%. Here's the probability of a foot or more. Okay, you can see where that's at. Generally, it's a 20 to 30% probability across the central United States, with the best probabilities in East Kansas at 45%. Okay, last thing I want to show you is the probability of ice exceeding 1/4 of an inch in 48 hours. That's going to be right here. Right now, that's the probability of the greatest ice accretion and the biggest ice impacts are going to be associated right here. Okay, and the one last thing I'll show, Brett, is at least the wind gust probabilities. We don't have suggestions of winds gusting over 50 miles per hour. We do very slightly on the far west end where the storm's stronger out in Kansas, Missouri, and Oklahoma, but it never makes it east. We do have winds that will certainly gust over 25 miles per hour with the system, though. They'll probably see gusts, 30, 35, but that's kind of a way for you to look at the odds of certain things occurring. Okay, so what we need to do now is just wait for more data, reevaluate, and say, hey, we don't have the answer yet, but when we get it, if you like, subscribe, and follow the channels, then you'll get it. Once we know, you'll know.
for sure.
If you get
And
clarity, you'll know faster.
yeah, and that's again, guys. There were some questions about it this morning, but we were updating clients this morning. Vince did a video. He made an updated map and whatnot on clarity, and that's always the fastest way to get things. And by the way, hey, we still have snow in the forecast. You know, we've got Snowski up there in the top left with his cowboy hat.
He's
Let's have
excited.
fun with it. No doom and gloom, right? Got to
Yeah.
be positive.
Yeah, we got to be positive. Yep, it's the weather after all. We're doing our best. That's our analysis right now. Again, we are just waiting to see which is it the high res data on the left that's stronger and more snow, or is it the European on the right that's weaker with less snow? We won't know much more until probably this time tomorrow. If we get a better consensus by the evening, we'll come on and share it with you. But once we know, you'll know. So thank you all. Share it with a friend, and we'll see you soon. Thanks,
Yep.
Brett.
Yep. Thank you. Thanks, guys.
All right. See ya.